What are chemical reactions and how do they occur? A chemical reaction is a process that leads to the chemical transformation of one set of chemical substances, the reactants, to another set of substances, the products. There are multiple theories which explain how chemical reactions begin and proceed to occur, and one significant theory is the collision theory. Collision theory states that in order for a reaction to occur, reactant molecules or species must come in contact with one another and collide. Of course, not all collisions will rouse the reaction, as they must be of sufficient energy, called the activation energy, and be of proper orientation. The collisions that meet those conditions are therefore successful collisions, and chemical reactions result from them. Chemical reactions differ from each other, not only in the reacting species and yielded products, or the set of physical conditions in which they are carried, but also in their speed. We call the speed of reaction the rate. The rate of reaction is a measure of how quickly the reactants are used up and their concentration decreases over time, and consequently, how quickly the products are formed and their concentration increases over time. There are various factors that affect chemical reactions and therefore affect their rate. One factor is temperature. With increasing temperature, the kinetic energy of the reacting atoms or molecules will increase, resulting in more collisions between them, hence a faster reaction. The video about to play is a simple experiment to compare the dissolution of a vitamin C pill in one beaker at room temperature, approximately 25 degrees Celsius, and an opposing beaker at roughly boiling temperature. Concentration is another factor which affects chemical reactions. When the concentration of the reacting substances increases, more collisions occur, and more often a reaction between the reacting species will arise. The presence of a catalyst increases the rate of reaction. Catalysts work on decreasing the activation energy, which is the required energy to start a chemical reaction. When the activation energy is lowered, the reactant's intermediate state is rapidly reached, as it requires less energy than the uncatalyzed reaction. Surface area or particle size affect the chemical reaction as well. Increasing the surface area and exposure of the reacting substances to each other will increase the number of collisions and therefore the reaction rate. Another factor which affects chemical reactions is pressure. As pressure increases, reactant molecules or atoms move less freely due to strict space. This restricted space causes the molecules to collide more, resulting in a faster reaction. The nature of reacting substances and bond strength impacts chemical reactions. Some substances tend to be more reactive due to their state or bonding. Gases, for example, have the fastest rates in contrast to solids, and this is merely explained by the frequency of collisions between gas atoms to those in the solid phase. The complexity of the reactant molecules also influences chemical reactions, in which the reaction rate decreases with the participation of more complex species, since complex molecules or ions are less likely to collide in a proper orientation and their complex bonds are less likely to break.